today we're going to be talking about two different rules. One of them is called the side splitter. So this is not with triangles. This is where you guys have parallel, it kind of looks like a train track, right? You have train tracks and then you have these little like roads or something that are crossing over them. So these aren't triangles, these are with parallel lines. So if multiple parallel lines cross two transversals, you're going to have two different transversals and a whole bunch of parallel lines crisscrossing them, then the segments of the transversals are proportional. We've been focusing on proportions this entire unit, so that should follow that when we have this situation, they would also be proportional. So when I'm talking about the segments here, I'm talking about the little pieces that the transversals have been broken up into. So when you draw those parallel lines, you can see how you have these little sections in between the parallel lines. So these two, if you were to write those as a fraction, would be equal to those two if you write them as a fraction. So those two ratios are going to be proportional or equal when you guys write out the expression. And that will happen in any situation. So as long as you have two lines and then at least three parallel lines, then these sections right here that I'm highlighting in this example, those will all be proportional. Alright, so in this diagram for our example, it gives us numbers instead of putting them in the diagram. We have to write them ourselves. So we know that PQ is 9, QR is 15, and then it says ST is 11. We're trying to find the length of TU. That's what we're trying to find the length of. So how do you guys think I would do that? If I know that these are parallel, and I know that these sections are proportional, how would I write that proportion?
9 over 11 and 15 over x.
You want to go this way, actually. You want to stay on the same side. You went like this.
Oh,
You want to stay along the same line here. So you first want to do 9 over 15, right? And over here you want to do 11 over x. Now this is one way to write the proportion, but remember on day 2 we talked about different ways to write the proportion. So we've actually been used to writing the variable first, right? In all the other scenarios when we've been writing proportions, except for the roller coaster rule and all that, we used to write the x first when we were writing the proportion. So if you guys want to stay with that pattern, you still can. So if you start with the x, how would the proportion look? Yep. Equals 15 over 9, right? It's these two reciprocal, right? So remember, that's one way that you can rewrite a proportion is to write the reciprocal of both of them, and it really doesn't matter which fraction is on which side. So if you feel more comfortable writing the variable first in the scenario, you can write it like this too. Just make sure that you stay on one side of the picture and then go to the other side of the picture to write it like this. It's a little bit different because we're not working between two similar triangles like we have before. We're working with two different transversals here. Okay, but whatever proportion you write, it doesn't really matter. When you cross multiply, you get 9x equals, I don't know what 11 times 15 is.
It's like 165.
Okay. 165?
Yeah,
And so then you'd have to divide by 9 to get your ultimate answer. 18.3. Right? And if you solved this proportion, it would give you the exact same answer. It's just written differently, but they are equivalent. So your final answer here would be the 18.3 repeating. Okay? So the only thing different here is just how you look at the picture to write the proportion, but you still need to use a proportion to solve. So our next situation over here, we're trying to find the value of x in the diagram, which is right here. Alright, so we know this is side splitter. Again, the way that you're going to know it's side splitter is if you see two segments like this, and then at least three parallel lines that are crisscrossing. Alright, so these segments right here that I'm highlighting, these should all create a proportion to help you. Right? Now the way that we're going to write this is a little bit odd. I know this is 8, I know this is 9, I know this is x, but I don't know this. So you have to stretch your brain a little bit. What would I write here? What can I write here to represent this length? If I know the full thing is 20 and I know this is x, what's that? 20 minus x, good. Because if this was a number, you could just do 20 minus that number to get this, but it's a variable instead. So we're going to have to write as 20 minus x. Right, that's what gives me that little section right here. So now that I have all four pieces, now I have everything I need for the proportion. So you guys get to start the proportion however you want to, just make sure that you finish it the correct way. So what would you like to write first in your proportion?
20 minus x will
You don't want to jump across the diagram. You need to stay on the same line until you get everything done, then you can switch to the other line, right? So if you were to start here with the variables, you can start with 20 minus x, and that would be over x. So you finish one line, then you go the next one, start at the top again, just like you did for this one, and what would the next proportion be? 8 over 9. Okay, and then once you set up your proportion, you can cross multiply like we've done before. So this would be 180 minus 9x equals 8x. Then what? What would you guys do from here?
You would do 8 plus 9.
Okay, so you would move so that the x's are together, right? And then what?
Then minus 1.
Nope.
You mean
No.
Divide by 17.
Excuse
Excuse me.
10.5882335.
So let's round to 6.6. Okay? 10.6. Alright? So when you guys have the side splitter like that, you do need to possibly find the fourth segment here, and you may need to do that weird subtraction trick in order to do that. So that's how the side splitter works. Again, you have two kind of railroad tracks that are like this, then you have 3 or more parallel lines chopping it into sections. Those sections will be proportional. Alright. We're going to do something similar, but we're going to be talking about proportions in terms of corresponding proportions instead of solving. So we're going to look at this picture to see if we can piece it together. So this is side splitter. So we have 2 different segments. We have segment 1 and segment 2. Those are our transversals. And we have our 3 parallel lines. Okay. So all these little sections here that it's been cut into, those are all proportional. We just need to figure out what goes where in these proportions here, right? So I'm going to undo this. So the first one says BD over DF, right? And then we have a missing piece and then EG. What's the missing piece that would finish that proportion?
C.
CE. Good. Alright, because we need that to finish the pattern with the proportion using side splitter. Alright, the next one over on the right here has AD over AE. Alright, so you switch the dynamic here a little bit. Oh, sorry, I messed it up. AD over BD, that's what I meant to say. And then AE over what would finish that pattern? Which one? Nope, not quite. Up here we had AD over BD, so we had this longer piece over smaller piece that's kind of overlapping. Then we had AE over CE. See how that finishes the pattern? We want the same pattern on both sides of the picture, so it should be CE here. Use color coding and actually mark down what they're saying, and it will help you see how the pattern should be finished. The next one says DE over FG, and then we have AD over what? This one's a little bit more abstract. Yes? How did you know that?
Because the DE is shorter than FG.
Okay.
And there would be like one more thing.
Section?
Yes.
Okay. So hopefully you guys can see in the picture you have small, medium, long with the vertical. Do you guys see that? Small, medium, long? Right? We also have that horizontally, they're just overlapping. We have the small, the medium, and the long. Right? So we were comparing the medium and the long sections to the vertical and the horizontal. So it should have been AF to match with the longest side FG. I know it's a little bit more abstract with the horizontal because they are overlapping, but they were comparing the medium and the long to the medium length and the long length for the horizontal. Okay? That's how that one was working. Alright, our last one here is AB over DF, and then missing part over EG. AC. So you get that pattern to finish. Okay? So if they're asking you for these corresponding parts, you can just draw in what you have into the picture and then artistically see how does it work? What piece am I missing? How do I get it to fill out in the diagram? That'll help you figure out what the corresponding part should be in the proportion. Okay? That's all you guys need to know about that one. side splitter, being able to solve using those proportions, and then being able to match up corresponding parts to finish the proportion. Alright, so that's all you need to know about that one. Our next one we're going to talk about here is also pretty short, how you need to work with it. It's called the triangle angle bisector theorem. Triangle angle bisector theorem. So basically what this says is a ray that bisects an angle of a triangle. Alright, so that would be this guy right here. Make a different color. This ray is what we're referring to. So if a ray bisects the angle of a triangle, it's going to cut the opposite sides into two segments, which are A and C over there, so that the segments on either side of the ray are proportional. Again, this is all proportions. Alright, so the way that this one works is if you have that this ray is cutting the angle in half, so you have to have that first. You can't use this rule unless you know that this ray is actually cutting the angle into two equal parts. When it does that, I usually refer to this as a river. I don't know how I started doing that, but that was one of the analogies I was using last year. So if you have that this is a river, these two pieces on the left-hand side get stacked together in a proportion, and then these two on this side get stacked in a proportion. See how I have A over B over here is equal to C over D over here. You don't want to cross the river. Don't try to say A is proportional, or sorry, A is in a ratio with C and B is in a ratio with D. You stay on this side, and then you stay on this side. Try the proportion, right? Don't cross the shape, you have to stay on one side. So that's going to happen in this situation here too. In the diagram, they're telling you that XY bisects ZXV. So we have this right here. They have to tell you that first. If you don't know that the angle is being bisected, either in the directions or in the picture with the marking already there, you cannot use this rule. So we have that this is an angle bisector, so I also like to highlight this to see how it splits the shape into two parts. What would my proportion be if I have these over here and these over here? Okay, so if you like to write the variable first, you can definitely do that. So I go A over 5, and then on the other side, 20 over 25. Just like we were going in the same direction between triangles, when we were doing proportions with triangles, you have to do the same thing here. We start on the bottom and go up. You need to make sure you do that over here too. So A over 5 equals 20 over 25. Match up these two, match up those two, proportion. Then when you cross multiply, you get 25A equals 100.
A equals 4.
So A equals 4. It's as simple as that. Okay, let's try this one. In the diagram, CAD right here is congruent to DAB right here. So what does that make AD? If these two are equal, what does that call that? Well, yeah, but specifically, it's an angle bisector. Okay, so because these two are equals, they're angle bisectors, so you're going to be working on this side of the river and this side of the river. So they're telling us that AB is 15. We know that AC is 9, and we know that BC is 14. I'm trying to find the length of DC. So this one's a little bit different. They haven't given us the information we need as straightforward as the previous one. Okay. In order to do the triangle angle bisector theorem, don't you need to know both of these two and both of these two? Okay. Well, I have this one. Check. I have this one, check. I have this one, check. Do I know this part right here? BD. I don't know that. 14 minus x. Yep, just like we did in that very first example on the top of the page. If you know the full length and then part of it, to find this other section, you would do the whole minus the part that you know. So 14 minus x. Alright, so now I have all four pieces. Now all you need to do is be able to stack them correctly as a proportion. So what do you guys think?
Wait, what's the one on the left?
This?
Yeah.
That's x. Because that's what we're looking for. They said find the length of DC, so I just called that x because that's what we're looking for.
It doesn't look like an X.
Well, that's because I wrote it sideways and I have a check next to it.
Oh.
Alright, how would I write the proportion?
15 over 14.
Say it one more time.
15 over 14.
So we're going like this, so 15 over 14 minus x, so we went top bottom on this side of the river. Then equals 9 over x. Whatever direction you get to, or whatever direction you go in, and you get to choose that, whether you want to go top down or down up, or start on the left or on the right, it doesn't matter, as long as you maintain that same pattern when you shift to the other side of the shape. So if you go 15 over 4 minus 6, 9 over x. Shift them equal to each other. Then you cross multiply, 15x equals 126 minus 9x. What would I do? You want to add the 9x? So you get 20.
Would it be 5.25?
Yes, 5.25. Right. So these are slightly different scenarios than we've seen before. They don't involve triangles except for this one, but we're not talking about similar triangles in this example or in the one above it. So these are slightly more strange to see and use, but just remember how to write. You're going to be split down the middle. You set these as a ratio, those as a ratio. Same thing up here. You're going to be split with parallel lines. You stick on one side of the shape, then you go to the other side of the shape. Don't try to jump across empty space. So if you guys see between here and here, there's a lot of empty space for you to jump over. Don't avoid doing that. That's not what the theorem says. Same thing with the side splitter. You don't want to jump over empty space. Like if you were doing this one, you don't want to jump like this, you're jumping over that empty space. Just stay on one side of the shape, and then you can go over with the equals. On the other side, the equal sign for the proportion, that's the side of the shape you would want to use. Okay? So if you guys turn the page, what I'm going to do here is I'm not going to practice specifically the side splitter and the triangle angle bisector theorem. I'm mixing all of the things that we've known, or that we've learned so far on this page. So this is everything. These are all the different methods we learned how to solve, using similar triangles, using side splitter, using roller coaster rule and splash mountain, and then using our triangle angle bisector theorem. So this is everything. These are all the different types of solving that we've learned in this unit. It's your job to go through this with me, practice figuring out which method to use and how to actually finish that question. Okay? This is going to be really useful because this is how the test is set up, right? It's not going to have a specific section for side splitter, specific section for the roller coaster roll. They're all going to be mixed together. So you need to be able to look at these, know what method to use, and then actually finish. Okay? So let's take a look at the first one. These are,
Parallel lines.
well, we do have parallel lines, that's true, but what shapes do we have here? Triangle. So this is a similar triangle question. Right? For similar triangles, you just need to match up corresponding parts, write a proportion, and then away you go. Alright, so the reason that the parallel lines are here is so you guys can figure out what parts are corresponding. So if you draw the little angles here, that can help you figure out what parts are corresponding to what. Okay? Gives you a little bit of a reference with the markings. So if I wanted to write my proportion to solve, again with these ones we typically start with the variable we're looking for. How would I write the proportion? Yes. You can if you want to, yeah.
Wouldn't it be side and side?
Well, we're not trying to see if the triangles are similar or not, because we don't actually know what the side lengths are, so we can't even confirm if they're similar. In this situation, they would say that they're similar to begin with. And they are similar by angle anyway. Alright, so how would I write the proportion? Remember, for these, we start with the variable, so pick one of the variable expressions.
2x.
Okay? So 2x corresponds with 10 in the other triangle. Remember, we're matching corresponding parts here. Then you go back to the original triangle. What corresponds with 3x minus 7? The 9. So remember, with similar triangles, you just match up corresponding sides and write them as a proportion. And then you cross multiply. So this would be 18x equals 30x minus 70. If you subtract this over, no, I'm going to go the other way. Well, regardless of what direction you go in, you should get, what is that, 12? 12x equals 70. regardless of what direction you go in to solve. And then when you divide, you will get a very strange looking decimal, but expect that in this unit. You get a lot of weird decimals in this unit. So it rounds to 5.8. There's rounding involved, you can just do one decimal. Okay, so that's similar triangles. That's the stuff that we learned first. Working with similar triangles. Alright, what scenario is this one? This is the angle bisector one. That's what we just learned today, right? So you draw the river to highlight that, and then how would I write the proportion?
A over 3 and 6 over 4.
Yes, A over 3 and 6 over 4. You go bottom up and then bottom up on the other side of the river as well. Then you cross multiply. Divided by 4. $4.5. That's how you finish that one.
For the first one that we did, could we just stop after finding x, or would we have to find the side?
No, they would just say find x and move on. Alright, so that was similar triangles. This was the angle bisector. What's this one? This is the roller coaster rule. Whenever you guys see the right triangle, right, we have the big right triangle with the altitude drawn. That's going to be either Splash Mountain or the roller coaster. This one's a roller coaster rule because they gave me a leg instead of the altitude. Okay, so how do I do the roller coaster? Where do I start? All over here. Loop the hypotenuse, and then, go across hypotenuse, loop the side that they gave you, and then come back to this section right here. So then if I do that, follow the track, what would my proportion look like? Yep. X plus 2 over 3 equals 3 over 2. Right, then I cross multiply. 2x plus 4 equals 9. Then what?
Minus 4.
Yep. Alright, what type of question is this one? This is our side splitter that we learned at the start. Because you have two transversals, right? And then these lines are parallel. They don't have a parallel marking on them. What do they have instead to show that the lines are parallel? Yeah, corresponding angles are congruent, right? So they could either give you the little marking to say that they're parallel, or they could give you angle relationships to show that they're parallel instead. So these are parallel. So how would I write the proportion if these are parallel and they've chopped up the transversals into sections? If you want to start with x, how would you put that side of the proportion together?
X over 17.5 minus x.
You're on the wrong one, buddy. Go up.
Wait.
Second row.
X over 9.
Okay. X over 9 equals 3 over 3.5. Again, if you start on the far left and go inwards, make sure you do that over here too. Start on the left and go in. Alright, so once you set up the pieces, remember you stay on this side, then you switch to this side, you can cross multiply. So 3.5x equals 18. And when you divide that, not 18, I'm sorry, that's 27. What do you get for x? Another weird, yep, 7.7. Don't be afraid of decimals in this unit. You will be getting lots of them. Okay. What about this next one? Okay, we're going to be writing proportions for all of them. I'm just wondering what kind of scenario this one is.
There's no way to draw So,
It is similarity. What do we do with these particular kinds of diagrams? Remember I called them something. Do you remember what I called them? This is a nested diagram. When you have one triangle inside of another, a teeny little one inside of a bigger one, what do we do to make it easier to see? We redraw them so that there's two. So we're going to draw them separately. So we have the smaller one here, and then we have the bigger one here. And then we're going to label the sides so we can see it a little bit easier. Okay? So in the small one, what would this side be? 3, and then the bottom? Okay. In the bigger triangle, what would that corresponding left side be? 8. And then this one down here? 16. So once you redraw the triangle, you can match up the corresponding sides now. I'm going to draw something inside. Alright? So if we start, like we typically do with the similar triangles, we usually start with the variable, right? So if I start with the x, what corresponds to x? 16. And then you go back to the original triangle over here. So how would I write the second proportion? 3 over 8. Alright, so separate the triangles, redraw them, and then you can see the matching parts and then write the proportion. So then you cross multiply 8x equals 48, yep. So x would be 6. Yeah, same thing for the next one. It is, again, two similar triangles with the smaller one kind of tucked into the bigger one. So you can redraw the diagram. Here's our small one. Here's our slightly bigger one. Okay. For the small one, what would these two sides be? The bottom would be, and then right hand side. And for the bigger triangle, what would the bottom be? 16, and then the right hand side? 18 plus A. Scoot this up a little bit so I'm not writing so on the screen. So if I write the proportion, what would it look like? 18 plus A over
8.
Okay. Equals? Yep. I know I erased the two pictures, but you should still have them. If you match the corresponding sides, you have the 18 plus A, the long side, or the right side corresponds with the right side, and the bottom corresponds to the bottom. Okay? So you write this proportion, and then you cross multiply. So you should get 216 plus 12A equals 288. Alright? Alright, then you subtract. Then you divide. 6. You divide 72 by 12. Alright, is everybody with me so far? Look out for those nested diagrams. Redraw the picture. It makes it a lot easier. Alright. Now we have our next two rows here. What would I do for this one? Same thing as the previous two, right? It's a nested diagram. We have two triangles, a smaller one and a bigger one. We go ahead and redraw them. So we have the smaller one, then we have the bigger one. For the small one, what would go here? X and 4. And then along the left-hand side for the big triangle. Sorry, left-hand side. This side right here. Combine.
2x plus 1.
Yeah, 2x plus 1. Because it's x plus 1, so you just combine like terms. And then this side would be 10. Okay, so once you redraw and label those sides, what would my proportion look like?
X over 2x plus 1.
Okay. Equals?
4 over 10.
Yep. Again, doesn't matter which triangle you start in, but whichever triangle you choose to go from, you have to go back to that triangle and you write the second ratio. So when I cross multiply, 10x equals 8x plus 4. 2x equals 4. X equals 2. Everybody okay with those? The nested diagrams, redraw, label? Yeah? Okay. What situation do I have here? It does not say that the angle has been bisected.
It's that cool arrow thing.
Oh,
It's that splash mountain, right? This is a right triangle with an altitude in the middle. And altitude is not the same thing as an angle bisector, so please make sure you're careful with that. So we have an altitude drawn in here inside of a right triangle, so I get to use Splash Mountain because the altitude was labeled instead of the leg, right? Now remember, for Splash Mountain, you go from here to here, and then from here to here, which I don't have. It would be 6 because they gave me the whole thing was 11, and then part of it was 5, so the other part has to be 6 to get that full 11. So what would my proportion look like? So the way the Splash Mountain works, again, you draw these 2 arrows, and then each ratio is represented by those arrows. 5 to x, and then x to 6. The arrows tell you how to write the proportion. Okay? Then we cross multiply, we get x squared equals 30. You guys remember what to do from here? Because x times x is x squared. How do I get x from this?
You have to do square.
Square root. Square root of 30. Right? Can I simplify that? Because remember, whenever you guys get a radical, you need to make sure you simplify it all the way. So can I split that into any perfect squares or anything? No? Okay. So if you can't simplify, you can just leave it like that. Remember, don't ever leave your answer like this. Okay, don't leave your answer like that. You do need to make sure you write it as an actual radical square root and then simplify it if you can. Alright, what scenario is this one? This is an angle bisector. Right, so that angle that they provided here, it is split into 2 equal parts. So I'm going to be using the angle bisector idea. This is my river that I don't want to cross, so I need to stay on one side and then move to the other side to write the rest of the proportion. So what would my proportion look like? Okay, so if you want to start with the variable, x over 4 equals 7 over 3. Okay, cross multiply, 3x equals 28. It's probably decimal of some sort. Yep, 9.3. Is everybody able to see the difference between the right triangle scenario and the angle bisector scenario? Hopefully. Yes.
So, with the,
For the angle bisector?
yeah.
No. You haven't bisected any angles. So for nested diagrams, just always redraw the picture. It's the simplest way to go about it. Alright? Alright, our last row here. Has anybody been having like significant trouble being able to tell what scenario is happening just by looking at the picture? Okay, because that, if you are, that is a problem you need to work on. Okay, so being able to recognize what strategy to use when you look at the picture is one of the most important skills here. Okay, so when you see this, what strategy would you want to use?
The split ruler.
Yep, side splitter that we learned at the top of this, or the beginning of this lesson. Right? That means these 2 transversals, this one and this one, they've been split into sections. And those sections are going to be proportional. We just got to figure out how to write them as a correct proportion. So, what do you guys think?
X over 17.5 minus x.
Okay. So you noticed that the whole thing from here to here is 17.5, but I need just this part right here. So I need to do this over this, the 2 little pieces, right? There are 4, 1, 2, 3, 4 sections. I need to make sure that I stack those correctly. So this section would be 17.5 minus x, like we saw in one of the examples on the previous page. So those 2 get stacked, and then how would I do if you shift to the other line? 6 over 8. Okay. So again, if they give you the full length and then just a part, you have to do that subtraction. Find the other one. So then I cross multiply, 8x equals 105 minus 6x. And you add that over. And then divide 7.5. Okay. What about this next one? This is another nested diagram. So I'm going to draw triangle big one and triangle small one. Okay. How would I label the smaller triangle? 4 and 3. 10 and x, good. Because this bracket here is already telling you that the full length is x. Do I need to do 3 plus x? No, because this bracket is already telling you that from here to here is just x, or they're already including the 3 in that x. So don't try to add those. The bracket is there on purpose to tell you that the full length is x. Okay? So how would I write the proportion?
X over 3.
Yep. We typically start with the variable, so we go from this triangle to this one, so x over 3 equals 10 over 4. Then you cross multiply. Another 7.5. Alright. And then we have our last one. What kind of scenario is this?
The first one.
Yeah, these are similar triangles. They're just not. So all these nested diagrams are also similar triangles. They're just a slightly different scenario. These are just straightforward similar triangles that aren't overlapping as a nested diagram. So this one, again, you're still matching up corresponding sides. They've just already been drawn nicely for you. So you guys have to tell me how to actually write the proportion now. So again, they gave you parallel lines so you guys can write the little markings in to help you know what corresponds to what, and to show that they actually are similar by angle. How would I write the proportion? How do I usually start the proportion? With the variable. And so that's the x plus 2 over 13. And then how would I write the other proportion?
13 over 20.
Okay, so maybe don't use the 32. 45 over 20. Alright, you can't use the 32 because they don't have the corresponding part, but you can use the 45 and the 20 because those are both there and they're corresponding. So then you can cross multiply. By 85. Subtract. Divide. Did I do all that right? I think I did.
X equals 27.
Alright, so these are all the different scenarios you guys will have. Those are all the different types we learned. The similar triangles, the nested similar triangles, the splash mountain and roller coaster rule, the side splitter, and the angle bisector. Those are all the different types of solving you will be expected to do. Alright, so being able to recognize the picture, know how to write the proportion, and solve, those are the 3 main things you need to do with these. Okay? Questions on that? No? Everybody's good?
That was fun.
Yeah?
That was fun.
Being able to figure out which one it is. Okay, so again, with more practice, it becomes less tedious. You get to see what needs to happen immediately. You go forward. Smooth sailing, right? Okay, so what you guys will be doing for the remainder of class